Alright, so this is practice from 422. First problem, you're asked to find f inverse and then find the domain and range for each. So if we first look at f of x is 1 over x minus 6. Think about the domain, its inputs. Well, we know that x can't equal 6, right? Because you can't divide by 0. So if you set the denominator equal to 0 and solve x minus 6 equals 0, well, that turns out x is 6. So the domain is everything except 6. So negative infinity to 6, and 6 to infinity. Okay, now the range is all about outputs. So we're dealing with a fraction here, and the only way to get 0 out of a fraction is to get 0 in the numerator. So if we look at what we're working with, the numerator is always going to be 1. So there's no way we can get to 0. So f of x does not equal 0. Now, that denominator can get, if you think infinitely large, infinitely small, we can go towards infinity or negative infinity. I mean, just think about what x minus 6 does, right? So if you graphed x minus 6, so there's your minus 6, it's a slope of 1. So it looks like this. So if you think about all of the y values along here, x minus 6 can be anything we want it to be, from infinity to negative infinity. So what happens when you take 1 and you divide it by, anything in between negative infinity and infinity? Well, this thing produces, everything from negative infinity up to 0, but not including, and 0 to infinity. If you want this fraction to be really large, you just make sure that in the denominator you have something really close to 0, like 1 divided by 0.00001. Well, you've got the ability to make x minus 6 equal to 0.00001. So that's what I'm trying to say. This fraction can be as large as we want it to be, right? Because you have control over x minus 6. You can make it infinitely small. You can make it 0.0000001. Also, if we take 1 and we divide it by negative 0.00001, we're going to get a negative answer, right? But it's going to be really big. Because this says how many parts that are this big fit in 1. Well, those parts are really small. So there are really infinitely many very small parts in 1. So that's why we get negative infinity. So we're talking about the range here. We can get really positive y values. We can get really negative y values, but we can never get 0. So that's why our range is from negative infinity to 0, union 0 to infinity. So our next step was finding f inverse of x. So f of x equals 1 over x minus 6. That's like y equals 1 over x minus 6. I'm going to try to solve that for x. So I'm going to get rid of the fractions. So I'll multiply both sides by x minus 6. So this turns into x minus 6 times y equals 1. We'll distribute this in, and remember the goal is to get to x equals. So yx minus 6y equals 1. Let's make some more room, which means yx equals 1 plus 6y. So get it to x equals, divide by y. X equals 1 plus 6y divided by y, which is 1 over y plus 6. So we've got f inverse. F f inverse of x equals 1 over x plus 6. Right, so domain, what can you and can't you plug in? The only thing you can't plug in is 0 because you can't divide by 0. So negative infinity to 0, union 0 to infinity. Now the range. Well, think about what 1 over x can become. We just talked recently about how it can become infinitely large things and infinitely small things, but never 0. So this can be really almost anything but 0. Well, if that can't be 0, then you're never going to be able to, 0 plus 6 would have been 6. But if it can't be 0, we're never going to get a value of 6 in our range. But we will be able to get everything else. Right? So our range is going to be from negative infinity to 6, union 6 to infinity. Right? So if the piece in yellow can be anything but 0, positives and negatives, then we're going to be able to, make 6 larger or make 6 as small or as negative as we want, and that's why we have this range. Okay, the last problem deals with exponents. So we're sitting here. We've talked about being able to distribute exponents in. We can make that call right off the start. So think about everything and its exponent. So this becomes x to the negative 2. This becomes y to the negative 8. On the bottom, you've got 3 to the negative 2 and x to the, 2/3 times negative 2. So x to the negative 2, y to the negative 8. Remember, this works because it's all multiplication. You can't really think about distributing an exponent if you have addition or subtraction in there. So 3 to the negative 2, x to the negative 4/3. So we're going to get rid of negative exponents and move things around. So 3 squared goes up top. X to the 4/3 goes up top. Well, everything up top has negative exponents, so it'll go below. Alright, so that's 9. We'll go x to the first times x to the 1/3 to help us simplify, over x times y to the 8th. We see that this will cancel out this. So that's 9x to the 1/3 over x y to the 8th. Now we're going to stop there because the rules that we were playing with said no negatives, exponents, no fractional exponents in the denominator. So there are no more full groups of x to take out in the numerator to cancel anything with the denominator. So we're done. We'll stop right there.